Hello guys and welcome to this video. Today our subject is quite fascinating. We'll finally share the code with the other developer, who's Jenny. She has been quite lonely during last videos because Bobby was doing all the work. So now it's her turn to do her contribution. To do that, we'll have to push the code to our bear repository. Remember, a bear repository is the one that we use only for sharing but not for working. And secondly, Jenny will clone the repository, and you'll see one interesting things about Git. You'll see why clone command is called clone exactly. Finally, we'll try to share the work the other way, from Jenny to Bobby. And if that works, we have the team that is all set to use Git. Jenny and Bobby seeing the same code, sharing the changes, and ready to work and build their amazing app. So now let's jump and start from Bobby's workspace. So let me quickly remember what we did last time. We have two commits. You can see them with help of git log, right? So we've got two commits, and we want to share the state of the system, the state of our program with Jenny, of our project. So what is the first thing to do if you're starting to work, you think to do something, and Git is to write git status. Remember this command, type it whenever you feel like typing it. And here we've got a small warning from Git that will go away after the next step. So the thing that we now need to do is to send our code from our local repository that is in Bobby's folder to the shared repository, which is a bear repository that we created a few videos ago. So to do that, we'll have to do one thing. I have to type git push add flag -u. We'll explain what -u does a little bit later. It is a setting for branches to track the repository. We'll talk a little bit about that later, but just trust me, the first time that you're sending the code over, you need to add this flag. In the next times you won't have to do that, but just this time set it, trust me, it's important. So we need to send, where we need to send. So the repository that we cloned from originally has a special name. It is called an origin. So what we want to do is to send to origin. And finally, we need to give the name of this branch, of this stream of work. And by default, the name of the branch is master. Right? So master is some central stream of work that you do together. There might be other branches, and we'll talk about that a little bit later. So for now, just hit enter and see the magic happening. Awesome, everything looks perfect. So right now, the repository, which is a shared bear repository, has all the information for Jenny to clone it, right? So let's do that now. Git clone, and the address of the repository is repos and camp git. That's our repository. And where do we want to clone it? Don't forget to tell where to clone it. Otherwise, Git will just create the folder called camp git in this folder, in Jenny's folder, but that's not what we want to do. So I just want to clone into a current directory, which is dot. Hit enter, cloning into current directory. And now I've got my main.js here. Awesome. So I can just try to launch it from Jenny's workspace. Node main. Horoscope app by Bobby and Jenny, that represents the latest state. But what's even more interesting and more important, why clone command is called clone, Jenny did not just receive the latest version of the code. What Jenny received, she received the whole history, the all commits that Bobby did so far from the beginning of the application, right? And if you type something like git log, you'll see that both commits are here. And it's not like when you type git log, Git does not actually go to a repository to fetch this data. This data, these two commits, are saved in the repository of Jenny. So now if I disconnect, let's say if the repository was remote, if I remove the directory, so if I destroy the central repository, Jenny will still have the whole history of the project safe and secure in her workspace. Right? In a little bit later, another spoiler, in later videos, I'll show you how to restore repository, just in case if the central is destroyed. But right now, Jenny is awesomely happy. She has her code, and now she can do the same thing as Bobby did last time. So she can change the code or add something new and send the changes over to Bobby. So now let's repeat the whole flow once again, just to make sure it is absolutely awesomely clear. So there should be no repositories without readme. That's what Jenny will do. So I'll create a file called readme.md, and I'll just type some text here. So all done, saving the file. What do I need to do to add this file to the project? So first thing to do is to call git status. See what's my status right now. And I've got an untracked file, which is readme.md. What do I have to do to make this file tracked? Think a little bit. And well, this is quite obvious because Git has a hint right here, git add file to include in what will be committed. And that's what we want to do. We want to commit this file. So we call git add, pass readme as parameter, hit enter. And now if I call status the second time, the file is green. And this is the changes to be committed. So I'm ready to commit my changes. And I type the third command, git commit. And I'll pass the message added readme. So the commit has been added, right? And now the commit itself sits in Jenny's local repository. I have not yet shared it with the world. So to share it, I need to call git push. And since Bobby has already set up all the things that's required to properly push, Jenny doesn't really need to add any more information rather than just git push. So now Jenny's changes are in repository as well. It's time for Bobby to get those back. And to do that, what Bobby will do is he will do git pull. So you're pushing the changes to repository, and it's like the symmetrical command. It's very easy to remember. Push, and what is the opposite is pull. You get the data from the repository. So let's hit enter, git pull, and you'll see readme.md has a couple of changes, which is 2 changed lines, 2 added lines. And if we see from Bobby's perspective how readme.md looks, you'll see the changes exactly as Jenny saved it. So now these two, following the same pattern, like commit, push, pull from the other side, commit, push, pull, they will be able to change the statuses of the files. Right? There might be some interesting cases. For example, when both developers change the same file, what will happen then? We'll see in upcoming videos. But for now, let's do a quick summary of what we have learned today and what were the Git commands that we explored. So our plan was to push commits to a bare repository. We did that? Well, right, we did that. So with the help of push command, Bobby sent his changes to a bare repository. So now the changes themselves are available to everybody. And what's important here, Bobby has not just sent the last status of the system, he sent all his intermediate commits, all intermediate snapshots of the system. Jenny cloned the repository, and also she got the whole history of the changes that Bobby did. It was just 2 commits, but nevertheless, she now has the full state of the system together with the history of the system. And finally, we tried to share the other way around from Jenny to Bobby. What we did to do that? So Jenny first added the new file, so she called git add. Then she called git commit to commit the file and create the commit. Then she had to call git push to send the files to the repository. And finally, from Bobby's side, we did git pull to get the changes back. And this is a quite usual, quite regular sequence of actions of commands that you will be executing in your Git projects. So, hope that was fun. Hope that you now kind of see the pattern how you share code with Git. And in the next videos, we'll learn even more fascinating things and facts about Git. See you then.